Good morning, this is Mrs. Gonzalez. Today's videos are going to be getting you to know all of the key features of an absolute function and a quadratic function. This video is going to concentrate on the absolute function. So before we can start on looking at what this graph actually looks like, I want you to think about what does the absolute value actually mean. So if I had the absolute value of 3, what would that be? Well, the absolute value is your distance from 0. So you want to write this down. Okay? So that is what the absolute value is. So the absolute of 3, if I was to think about a number line, my distance from 0 to 3 is 3. Same thing if I did negative 3. So if I find negative 3, let's put that in red, is over here. That is 1, 2, 3 spaces away from 0. So both absolute of 3 and the absolute of negative 3 is both equal to 3. All right, so when we are doing a table to how this graph should look, I want you to think about this in terms of your distance from 0. So one thing that we love to do, mathematicians do, when they are graphing functions is to use these 5 magical numbers is what I call them. So we're going to look at a table because this table of values lets you graph 90% of the functions. We usually use -2, -1, 0, 1, and 2. So the reason I say 90% is because I can take all of these functions and move them left, right, up, down, and then sometimes you don't see a clear picture of all of your graphs. But 90% of the ones the textbooks give you, the SATs give you, your tests and quizzes give you, the majority of them, if you use these 5 magical numbers, you get to see what exactly is going on with your function. Okay, so this is always a great starting point, is to start with these 5 numbers. So now what I would do is, let's plug it in. What is the absolute value of -2? Well, we talked about that as the distance from 0. So what do you think it is? That would be 2. So when I'm going to go and graph this, this would be the point -2, 2. Okay, so let's put our axes on. This would be -1, 2, 1. And -1. Okay, so the point -2, 2 would be right here. So now let's do the next one. What would the absolute value of -1 be? Distance away from 0 would just be 1. So now this is the point -1, 1. Okay. Now we continue on with 0. Absolute of 0, how far is 0 away from 0? Well, nothing. And now let's go to 1. And this is the value of 1. So this is the point 1, 1. And last but not least, we have the absolute value of 2, which is 2 away from 0. So we have 2, 2. And this will be. So one thing that you do want to write down is that the absolute of x is called a parent function. We call parent function what happens before we move it up, down, left, right, upside down. Next class, you're going to look at all, these are called transformations. You looked at them in geometry, and you're going to look at how transformations affect the graphs. But we always talk about how the transformations changed what's called as the parent function. So the absolute of x is called a parent function. What you also want to know is that this is a V-shaped. All absolutes are going to be a V-shaped, which is very important to remember. That's how you can tell you have an absolute function versus a different type of function. And the transformation form, which is what we're going to look at, because all transformations are going to be, you might have a number out in front. We're going to find out next class what these letters do. You might have a number that's inside the brackets or parentheses. Now, one thing I like to say over and over throughout the year, anything that is inside brackets or parentheses is kind of a liar, and you'll see next class why I'm calling it a liar. And then you have plus k on the outside. This is what we are going to call the transformation function, and if we have numbers in place of a, h, and k, they do something special. And we will look at that next class. One thing that you want to keep in mind as we start to look at this next class is our vertex, which is this pointy part of the V, is always going to be h comma k. And we again can look at that more next class. Okay, so last class you talked about domain, so I want you to think about what do you think the domain would be. Well, if we look all the way to the left, furthest left, if I follow these arrows, is negative infinity. Furthest right, if I follow this, is positive infinity. And that would be my domain. My range, remember, is the bottom of the graph, and if you look here at the bottom of the graph, I hit 0. Now I touch it. Whenever I touch it, I use this bracket because I touched the value. I was equal to that value. And then I go to the top of my graph, which if I follow the arrows is going to be positive infinity. That is everything you need to know about an absolute function. Next class we will talk about transformations and how the transformations change the look of this special V. Here is a screenshot of what we just went over. This is how your book points it out. So I wanted to also just capture it quickly for you. You have the majority of it on the other page that shows you how to do, but you are going to see this in your book for the try it section. So I wanted you to see how their notes show it. The one thing I didn't talk about in the video over there is the axis of symmetry. So axis of symmetry is an imaginary line that if I was imaginary vertical line, that if I was to draw a line down, it cuts my function in half, and I could actually fold it along the line and they would line up perfectly. There are several functions that have an axis of symmetry. Axis of symmetry is always going to be x equals h. And we'll look at that a little bit more as we go as well.